All right. 30 minutes on the timer. Go. All right. Hey, everybody. Okay, so I'm going to start with a little story from the past, and then we'll move into kind of what Node is today and how we can move into the future. So back in December of 2009, this is right after Ryan Dahl announced Node at JSConf EU. My friend Jan Learnhardt, who was an organizer of JSConf EU, said, "Has anybody written a node.js HTTP proxy yet?" And so about 5 years ago, nobody had yet. and I looked and I was like, "Oh wow, nobody's actually written this yet." That'd be a fun first program to write. Like, this looks interesting. I want to play around with this node thing. And I knew a little something about writing proxies. I had written a proxy that was part of a test tool called Windmill. It was a very fancy proxy. It did all kinds of fancy forwarding and stuff. But the part of it that was just an HTTP proxy that just brought data from here to there. It was in Python. It was about 10,000 lines of code. It had a lot of third-party libraries, including ones with fixes on top and all this crazy stuff to make it actually killable, and it was just nuts. But I spent 3 years optimizing this proxy, so I knew a lot about writing proxies, actually. And so I was like, okay, cool, I'm going to try this node thing out. Sounds rad. So 2 hours later, I had this. So raise your hand if you were writing Node around the time that this kind of code would be written in Node. Yeah, okay. It's like 2 of you. 3 people. Awesome. Okay. So for those of you that weren't around this far back, we've come a long way. So if you look at this program, the first 10 lines of this function are just parsing URLs, because we didn't have an URL parser yet. So I had to just do that myself in line. The old HTTP client, before I kind of went in and rewrote a lot of it, you would create this client object for a port in a server, and then you would, if you look at this var proxy request equals line, there were methods on it for every HTTP method. So if you want to do a get, you had to do .get, which is really annoying when you're doing proxying, because you have to do this whole method to lowercase thing here, and it's just very hacky. But then you pass in to proxy request the path and the headers. Why did you have to do 2 calls? It doesn't really make any sense. So this is where it gets interesting, though. So if you look at the bottom, we add a listener. There's no on yet. We don't have that. So this is it's now just on, but this was add listener body for chunks. Then when you get chunks, you write them using the send body function. Okay, and then here's the second half of the code. Then you wait. Okay, so then you call a function called finish, which gets a single callback, which is totally different than every other message signature in the rest of Node core at the time. Then you call this send header method, which is strange because you actually send all of the headers. Then you have to do this encoding thing. This encoding thing here, it says binary, right? And we're setting encoding to binary. It's not actually binary. It's a binary encoded UTF-8 strings, because we didn't have buffers or real memory allocations yet. In Node, we had these horrible binary encoded strings. So then you add a listener for the body event. So if you go back here, on this thing, you have body events, and then you go send body chunk. And on this one, you listen for body events, and you go send body chunk. But then you listen for this complete thing, which is totally different than this finish thing. Why do these 2 objects have totally different APIs? I don't know. That was just how he decided to write it. And then you call a finish function that doesn't take a callback, because that's not confusing. And then you do sys.puts to actually print output, because it would console.log would have been where people were looking for it. So we had to invent a new thing. So yeah, not super great compared to today. But compared to the Python proxy that I'd spent 3 years writing, this thing that I wrote in 2 hours, when I hit Control-C, it actually died, which was the greatest, most liberating thing in the entire world. If you've ever done a lot of Python programming, things are unkillable. You just can't get rid of them. But it was about 50 lines of code as well. And it was significantly faster than the Python proxy that I'd spent 3 years optimizing. So yeah, so it was much better. So 2 months later, this code changes pretty dramatically because we're now like improving Node. So hey, we've got an URL parser that gets rid of like 10 lines of code. You can see that we now have this request event this request method on the client object. In like the 8th line here. So this guy. So now we can just pass it the method name. That's nicer. We still have this unnecessary call, but we're doing this now, so that's a lot smaller. We don't have that crazy finish thing anymore. We listen for a response event. That's nice. The binary setting coding is a little bit less hacky, but it's still those awful binary code strings. But hey, we have this add listener for this thing called data, and then we write it, and we listen for data, and we write it, and we call close on both of these things. So they're like starting to look the same, and they're not unnecessarily different. That's pretty awesome. A few months later, in July, about 4 months later, July 2010, it gets reduced a lot again. And that's because now that these objects are starting to look the same, we start to talk about this thing called streams. And we're starting to call them streams and refer to the things that we're writing in core as streams that have this sort of unified interface. And so I get a patch in the core that adds this utility in this called pump. And so what pump does is it says, you give me one stream and I'll send all the data to the other stream. And that got rid of all of that boilerplate that was figuring out how to send data from one area to the next. So that was awesome. Then 9 months later, in March of 2011, it gets smaller again and nicer again. So request is like a lot cleaner, and we don't have to do that client thing anymore. But the big one is that now all streams have a pipe method. So sys.pump can go away, and it's just much smaller and simpler. It looks kind of like more like Unix pipes. So we're really sort of figuring out like how streams can look, and this whole time, like we're just reducing the code even more. Everything is getting faster. You also notice that like the set encoding thing is gone now because we have buffers. Yay! We actually have real binary types. That's awesome. So then a year later. No, wait, is that a year later? No. That's like 3 months later. So 3 months later, it reduces again. And this is because, so request has been around since before NPM, actually. It's like one of the first libraries that I ever wrote. I had this crazy idea where I was like, well, if streams can kind of like, if a stream knew about its input and its output, so like the pipe method is on the stream, right? So it knows where it's sending data to, but how does it know where it gets data? And so I added a patch in the core that added this event called pipe. So now when you pipe something to something else, it actually triggers an event on the destination that says who is piping to it. And with that, I was able to turn request into a stream that would actually do all the proxying for me. So this whole proxy server use case gets dropped down to 3 lines now, which is like phenomenal. And request really takes off at this point. And then in November of 2011, I think it was either Ryan or Isaac had the great idea that pipe should return the destination so that you can chain pipes together, which now reduces this down to 1 line. So that's how we get to the 1-line proxy. And this is really sort of like the whole history of Node, is that we keep making things simpler, we keep making them smaller, and we keep adopting these really small fundamental patterns that connect things together. So that we can build this amazing ecosystem. So for the last few years, I've been collecting a lot of data on the growth of different open source ecosystems so that we can try to compare them more objectively than you can just with raw numbers, but also so that we can predict their growth a little bit more accurately. So this is a chart that I came up with in April of last year. And I got a text from Isaac the other day that told me that last month we went over 100,000 modules, and I predicted it to the day in April of last year, so that's kind of awesome. Some of the other numbers are not as easily predictable. The big one is that, so this was done before Packagist in PHP had really taken off. So pair is only on here. But PHP Packagist actually has a really good growth line now too. So it's going to, like, if you put it on here, it would actually overtake Ruby Gems at some point. It's looking really nice as well. But Node's line has been very stable and really looks like this. So, you know, this is where we went over 100,000 modules, and it looks like we'll hit 200,000, you know, sometime in 2015. So, yeah, like less than a year away, we'll probably hit 200,000 modules. And this growth, this insane growth, like nobody even understands it. It's really due to three things. So if you're going to point at some things that Node did right, other than NPM, these are the three things that Node as a platform got right and allowed us to have this giant ecosystem. So one is the module pattern. And I mean, like, you've probably used modules. Many of you have maybe written modules as well, hopefully. But this module.exports equals function is really amazing because what it leads to is people publish a module that does one thing, and it has one simple API for the easiest case, and then it might have other methods attached to that for non-simple, non-trivial cases. But it means that documentation is simpler, so we can write smaller things, document them well in a README. Everybody can learn it more easily. The community grows, more people write modules, et cetera, et cetera. The next is the callback pattern. And you know, I don't really want to get into promises and all that stuff lately, but as a compatibility pattern, so forget about sort of when you're managing lots of callbacks. As a pattern for compatibility between, like, I wrote a module and you wrote a module and I've never met you, this is a really great pattern because if I take a callback, I can just pass that callback off to you, provided that you follow this pattern. And it's very thin, it's very lightweight. I don't have to create an object. I don't have to make sure that the object that you passes me implements this thing. It's a very simple compatibility for you to pass responsibility from one module to the next. And then the stream pattern, which we've talked about quite a bit. But the stream pattern is very important. So now everybody who publishes something that processes data iteratively, or that works with a socket, or that works with a file, all of it can work together. And we can put them all in a row and make them all plug into each other. But, you know, this isn't everything. I mean, Isaac Roth told you earlier, like, there's new stuff coming into the language. We've got generators coming in. People are starting to get really into promises again. Although I'm still skeptical, but how does Node continue to adapt to these new patterns and take them on if we have 100,000 modules that use these, right? Like, you can't really compete with 100,000 modules. You really have to go and build a whole new ecosystem and incentivize a bunch of new people to join that if you're going to break these patterns. But how are we going to innovate? How are we going to use new stuff if we're stuck here, right? And the most unlikely person showed me a way forward, and that was actually TJ Holowaychuk. So this is Co. I think Isaac had an example earlier that used it, but Co is a very interesting module. Co and Funkify are both, like, really important modules. So Co is a function that takes a generator. Okay, that's what Co is. And what it returns is kind of interesting. It returns something that is essentially a generator or takes a callback, right? So it implements, it scales down to the API that the rest of the ecosystem uses. But within my code, I can use generators as much as I want. And then there's these 100,000 modules that use callbacks. So, like, what do we do about those? With Funkify, you can just pass it anything that takes a callback, and it'll turn it into a generator, right? So this reduces all of the taxes that you get when you try to compete with a compatibility pattern. It basically takes a new pattern, something that we want to adopt from the language, and it wraps it up in all the old compatibility patterns so that we can still continue to be compatible with 100,000 modules. We can continue to grow that ecosystem. And like, I don't have to worry that you use a generator if I want to use callbacks. Like, that works fine. And they don't have to care how I implemented something. It's really nice. So, yeah. Here's some more like really simple examples. So this is code. Like, I just wrote this thing that uses generators, but then you can call it with a callback. That's really cool. It's really nice. It's smart. And, you know, if people get sick of wrapping up everything, you can just publish, you know, a module that does exact, but in a coroutine. My favorite part is that, you know, we can still publish a module where the return value from co is the module. So now everybody who's expecting to be able to use that with callbacks, it's going to work. But also this return value is also a valid generator. So anybody who publishes stuff with code that's already wrapped up, people that use it don't have to use Stunkify. That's really cool. I had one more example, but when I was going through it earlier, it was just so complicated to explain. I was like, I'm going to lose everybody. It's just not going to work. But essentially, the stream pattern, we can continue to extend it to do other things. Like, request is an example of this, right? Like, request doesn't just send data from one object to another. It actually interprets what you want to do with these inbound and outbound objects. I have another library called response that does something very similar for HTTP responses and servers. So that was Node past, present, and future. I'm up way early, so that's great, because now I can take questions, because everybody probably got lost because I was talking too fast or something. So, and yeah. Oh, and I'm Mikeal, by the way. And I'm the director of evangelism at DigitalOcean, and I run a conference or two.
What's
up?
So you kind of alluded to new things we can do with strings, or new functionality strings can have.
Yeah.
Can you expand on that?
So the question was, I alluded to new things that you can do with streams. It's not new things, it's extending the pattern, right? So we're essentially changing the meaning of pipe, right? So pipe, as you sort of think of it, just streams define pipe as it takes data from here and it sends it to there, and it sets up some flow control so that if things get paused, that we don't buffer indefinitely. But we don't have to be satisfied with that, right? Like, the interesting thing about streams is that if you implement an API as a stream, like as a stream object, even if you're not streaming something, you can always scale it down to being a stream anyway. So a good example is if you look at my response library. Actually, I'll just pull it up real quick. This is easier. Okay. All right. So if you look here, response. Oh shit. Let me see here. I want to just like break this out. Oh, come on. Nope. Oh, here we go. Okay. Ha ha ha. Okay. There we go. All right. So if you look at this first line here, response.html, and then you give it the HTML string, and you pipe that to response, to the actual server response. So what this will do is it'll, set the right content length header. It'll set some cache control values that are really smart. it doesn't need to stream anything, right? Because we just passed it the whole thing. But if I don't pass it that, if I pass it just if it's just empty, then it is a stream, and then it assumes that something's going to get piped to it. And when that file gets piped to it, it's also going to go, oh, I know that that's a file from the file system. I'm just going to stat it and get the content length so that I can set the content length header properly. So rather than saying that pipe is send data from one place to another, it's really pass the authority, like all of the context of this object that you can figure out to this object, right? So it's basically an API for passing objects to each other, not just sending data from one place to another. And I think that there's more that we can do and extend that, right? I mean, yeah, request does a ton of it, like a ton. And some of it is very, very complicated, but it should be cleaner once we move into streams too.
じゃあ次なんか質問的にある人。
Guillermo has a question of it.
So I would like to ask a question.
Okay.
Where do you would like to handle our community, our community?
So wait, so handle?
I mean, you want to go the next Node.js community.
Where do I want the Node.js community to go?
Yes. Mars.
Yeah. Space. So Node is more successful than anyone ever thought that it could be. I mean, the highest benchmark for a platform like Node, when we were first talking about this stuff, like the first year that it came out, was something like, oh, it could be the next, Rails. Like we could, and we will write some servers, but people won't do this and people won't do that. It's gone in and has a significant market share, actually, of new hardware and IoT. Nobody thought that was going to happen. People are actually writing articles, and huge companies are moving from Java to it. We never thought that would happen. I mean, when you look at the growth of Python and Ruby and those languages, it took them 20 years to try and get like a couple people to move their testing tools off of Java onto those frameworks. Like, they're not moving infrastructure to it. But as the community has exploded and we've gotten 100,000 modules, core has really died. And a lot of it is that everything that makes the community work doesn't hold true for core right now. So core, the community writes all these tiny modules that connect to each other without a lot of coordination. And everybody owns their little project, and all of us sort of contribute freely on GitHub to all of each other's projects. And everybody releases really often, and they push like proper sem there so that we don't like screw everything up, at least most of the time. And that's working. It's working tremendously well. But none of that is true for core. And so over time, like we've shed contributors. The model is out of date. And so what I want the Node community to do is that the Node community should actually start to work on core. And there's some really fundamental like governance and ownership questions to fix first, because there is a big community that wants to work on core that isn't, and the situation that we didn't get to overnight. There's a long history of the project slowly bleeding contributors, at the same time that there are more Node developers every month than there were before.
The situation is changing. So what the purpose of do you create the Node forward?
Why did I create Node forward? Well, it's essentially for that. So there's two big reasons. One is there are some issues, even if we don't figure out core right now, there are other issues around core that we can just take responsibility for. And we don't have to be managing core in order to fix them, right? We can actually figure out a roadmap and figure out where we want Node to go as a community, even if nobody's committed to it yet, because we can find people to commit to it, and a lot of the contributors are on board for that. There's also a few other problems that have just been very difficult to figure out with this really anarchistic distributed community of tiny modules, right? Like there are problems where when you have to put a bunch of things together, you need a few people to coordinate with each other and talk to each other. And so that we're doing that for Node Forward as well. So Node Forward really is just like a place where the community can come and own the process and own the projects that we're working on and show a better way forward for Node, and then we will figure this out and inject this into the core project over time.
Okay, thank you. 僕が最後に話したなんでノードフォワードを作ったのかっていうやつは、結構実はですね、僕は一回翻訳してるんで、ノードフォワードとは何かみたいなやつが僕のブログに上がってるんで、その話もちょっと話してくれてたので、そこの話もちょっと見ていただけるといいかなというふうに思います。じゃあ一応これで時間はだいたい過ぎたので、一旦終わります。もしなんかまだマイケルに聞きたいことがあれば、今次会までいるということなので、よろしくお願いします。じゃあ一旦マイケルに大きな拍手を。